Oh my God, AC. Can you take my notes?
By then, everything is running. Running the running email the first thing one of them began just then and they had a running
It's nice to know where you came from because you say you're making some of the same mistakes. You can only know you made the mistake if you know about the mistake.
Very good at it.
Go back to source routing again.
A long time ago, in one of these on Jaco, I find they were trying to do taxes. I proposed to, why don't you do that? Why don't you do taxes? And I was blamed for that. And now we're doing it. Somehow, Steve became confused by that. How much brain people are together? Getting when they're wrong.
More importantly, how the person they have.
It's not that hard to,
All right.
in ISIS, basically find a priority rule that says modeling the node. Pick the one that has priority for the priority rule and use that as some plotting, and the timer for plotting expires. No, it becomes deterministic. It's going to be that. It's going to be unidirectional, but it's going to be deterministic given it's a learning approach. No. You can call it, you can break down the order of using the circuit. Or picking the link.
I think I have enough to say it's playing machinery in my head.
It's proper. Everybody that did full networks in the old days, they handcrafted this all into basic. And they looked at the physical topology, and then they crafted like 2 or 3 paths and blocked everything else.
Well, it's effectively what the here, the one with nitro-rest, one with IETF98. They basically come down. Basically, you're dealing with the fact that for each choice topology, know which thing should go.
So this is the ISIS working group. We're going to get started very shortly here. As soon as my minute taker gets off his phone call. Oh, yeah. It's because I'm trying to do too many things at once. So we have 2 chairs. Yeah, thank you. You want to give me one and I'll do one. Yeah. 8:31. Yeah. Okay. Do you want to try? Well, I did set up an Etherpad. Lou loves this thing, so I was gonna try it. It's at Etherpad tools IETF.org, the standard place /p/ISIS-IETF-98.
It's off of the
Oh, that's a good idea. Yeah, go to the off the page everyone has access to. Okay. So let's see. We have blue sheets. We have written taker. I don't know if there's anybody who wants to do a Jabber scribe. We usually don't have anybody who wants to do that. And meet echo. Okay. Oh, yeah. Here's the note well. Anything you say in this room will be recorded forever and will be considered a contribution to the IETF. Anything presented, said, so forth. So here's the agenda, if anybody wants to bash this at all. It's, I don't know if I have myself there, but yeah. So a quick document update. We have 2 documents that have been submitted to the ISG, the AutoConf, and the changes to EMMA multi-instance to add multi-topology to it. Neither of those seem to have any blockers, so we should have our RFCs shortly after this IETF. You see Les over there frowning. We hopefully will have L2 bundles. Aliyah, do you know, did Hannes submit? I know he sent you something, but I don't know if it was official submission to the ISG.
Oh yeah, so yes, he did a Shepherd's report. There are a couple concerns that he expressed, and I thought it would also be useful to talk about the approach that ISIS is taking for this in a more general, like RTGWG or something, where people are thinking about it for OSPF and for BGPLS. It all ties together. So, some of the concerns are the usual carrying around the kitchen sink in ISIS when it's not intended for use there, and some of it's is this the right representation of the L2 members and so on. So I don't have a strong opinion, but I did think that pointing it out might be useful. Some of the details of how we represent layer 2 links or even merged layer 3 links came up in RTGWG a while ago when we were working on composite links RFCs. So
yeah, I mean,
I need to think about it.
I kind of know Hannes wasn't entirely happy with this, but at the same time, he's one of the co-chairs of this working group, and he had plenty of time to express these so that we could address them. The draft has been accepted, for months and months, and then the note write-up, and then we get a write-up, and now we need to take it back and discuss it in front of people. I mean, it doesn't seem like a very proper procedure to have followed.
Yes, you are right, and I had been suggesting that with IETF coming up now, not in the absence of that communication, still think it would be useful to point it out to RTGWG. I need to spend more time talking to you and get a better understanding of some of the other perspective around it. I did read the document, of course, for my review and thought it was, I did not see technical problems, though I certainly understood the concerns that Hannes was raising.
Right, okay. Well, here comes Les. Here comes Peter. Peter Lothberg.
I'm Peter Lothberg. Don't we have an IETF process? Can't we just follow that?
Yeah, that's what we're doing. In the slowest possible form possible.
No, yes, Aliyah, yes, we have an IETF process. Yes, we can follow it. I think the short form is going to be send a notification here. We're progressing this IETF last call for RTGWG and OSPF folks, so their awareness is raised that if they think they're going to want to represent things differently, they can. But I don't intend to have this be a long issue.
Okay.
I see no reason we can't progress it rapidly.
We're going to last call it and let those groups comment in IETF last call.
We have an IETF last call. Sometimes it's exciting to have comments during it.
Yeah, okay.
So just to put you on the spot, yes, I know. So I'm just trying to understand what's the progression of this document at this point, because it passed working group last call, I think last June, and it has not moved since then. We have implementations that want to ship, and we don't have code points, and we didn't think we needed early allocation because we had already gone through last call, and we assumed with, sort of the normal turnaround. So what's the timeline?
Oh yeah, so Les, you just gave me substantially more information than I had about this document. What I had was, oh yes, it's coming, and then I got a Shepherd's report that expressed some concerns on the carrying around it. The way it's described in the document is sort of application level data, and I also look at it and say, if we do it this way in ISIS, we've got implications with OSPF and BGPLS. Not that the people in the room here aren't a lot of the same people who are in the room there. So I'm not really concerned that there hasn't been coordination. So I'm formulating a plan now, which is why I'm pausing.
You can answer after the meeting too, because then I can move forward.
Okay, so short form is, my expectation is raise awareness. I will probably do another AD review of it and try and get into last call. The code point issue, I mean, we should not be in the business of standing in the way of having implementations that are following the document blocked because of code points. That's ludicrous. I mean, given that the working group is happy with the technical direction, so my inclination on hearing that information is to say, right, I'll do another solid review of it, send the comments to the list, though as I said, I didn't notice anything obvious that screamed at me, and get it into IETF last call. I may do raised awareness. I might throw an extra weekend, partly because I'll be on vacation anyway, and then put it onto telechat. So assuming that there are no concerns, I expect that we could do it on the telechat in early May.
So I just want to point out, I just want to point out that we are trying to run the internet out there, and we would like to get our protocols so we can actually expand our infrastructure to get better thing service. And the fact that the IETF is not really helping us making the internet better puzzles me.
Okay.
Maybe
you're going to have to answer them after. I'm like, this is supposed to take 3 minutes, and we're 13 minutes in. Okay, so new working group documents, the ISIS encapsulation, the segment routing, MSD. I think that OSPF might even be like last calling that one. We just adopted it. Much slower here. Oh, okay. And that's, oh, right. I thought that was, so this is segment routing Yang model. These are the updated documents. We have a presentation on the Yang model. And most of our presentations in blue there are new individual submissions. You can see these updated, and these are ones that are just sitting there. Oh, the interesting one that's just sitting there is that we have a very long call for adoption on the Baker desk source routing. I brought this up in routing area, I think, and we need to, right now, I said it was, we had 2 comments. Les saying, so maybe, let me hear about some people that want to use it. And we have the authors supporting it, obviously. And then Mikael Abramson also said that he would like to see it move forward. It would help to have a little bit more interest shown. It is kind of a big thing. It's a lot of stuff going on in that draft. Anyway, so it's sort of stalled there. If people are interested, you could probably push, and given that no one objected, it would get adopted. Okay, so let's get on to our first presentation, which is Stefan. Hopefully that doesn't hurt. Here's your, I just plugged it in. I don't know if it works. Let me get your presentation, sorry. And, oops.
Okay, so this is an update about the segment routing ISIS model and also the base ISIS model. So it's a very short summary, so there is no Yang diagram or whatever, so please look at the draft to go into the details. So the main changes that we done are mostly cosmetic changes. So the first one is a strong alignment between ISIS and OSPF modeling in terms of name of containers, name of leaves, and so on, to have a kind of So if I want to configure OSPF and ISIS, it's very similar. We're also fixing some compliance with the keychain model, as AC is always changing the way it's modeling the keychain. I hope it's stable now. So this is fixed now. Yeah, great. And I also published a new version this week that is taking into account the routing types that have been defined by the design team. So now we are also using those types. So this is globally what we've done with the base ISIS model. So now, what's missing? One of the biggest missing point that has already been mentioned in the OSPF working group is the routing policy, which is really important for ISIS. So we are waiting for the policy models that has been defined in RTGWG. So there was an update from Rob in the OSPF working group, and I had also a chat with Rob on this. So globally, correct me, Rob, if I'm wrong, but you are planning to refresh the draft. Normally it's stable, so we are able to use it now. So this point may be, yeah, this is not a blocking point anymore, I think. Do you want to add something?
We've just got 2 or 3 sets, sorry, Rob Shakir, Google. We've got a couple of things that we're going to push just based on some implementation experience, but I expect like next week or so we should have something merged. And I just mentioned that's also implemented on quite a few platforms right now, so you might be able to use it as well.
Yeah, the main point is we need to have something to call the routing policy, which is not changing anymore. Yeah, that's all. Okay, and the last point was about the operational state. There were a lot of discussion this week about how to model this operational state. So currently we have a dual tree, so 1 tree for the configuration, 1 tree for the operational states. Yeah. Do we need to change it? Do we need to keep it like this? Yeah.
I think on that one, like I think we just need to make sure that everyone agrees what was said this week. So maybe I don't think we're going to block on this. It's either going to be everything under the routing branch or keep it the way it is. And we should be able to make a decision on that like next week or something on the mailing list.
Yeah. Oh, yeah, I'm sorry, I was confused with the policy model one. That one is supposed to be revived, and there's plans to move forward with that and the BGP models, which also depends on it. So I expect to see progress fairly soon on those. On the operational states, the primary consideration is implementations. And we're working on the more detailed guidance. I don't know what the state of implementations are as far as the dual tree piece. I think it's something where I'm happy to have discussion and be pragmatic. I do think in the longer term, we're moving away from the dual tree. And so there's a risk that if we do the dual tree just because that's what's been done, but not because we have implementations that don't want to change for it, that we'll have to revisit it in the future. And I think it's going to be more confusing in terms of where you pull from. But if we have implementations, that's a very different story. I'm not willing to keep turning those.
But I think implementations are also waiting for an IETF position before trying to do something.
So if they're waiting for an IETF position, we really are going to get guidelines out. I've been trying, and it's Friday of IETF is not the best time to make critical policy decisions on not enough sleep among a group of 15 people.
It's got to be the best time, right? You can sneak everything in now.
That would presume that I were not one of the one of the exhausted individuals. Then I could have strategy like that. Thank you for the suggestion. It would never have occurred to me before. But if there aren't implementations, my preference would be to be going onto the train 1, because I think that's the better intermediate solution, which will still allow implementation now instead of in like 10 months.
AC Lindum, I think at least for a couple people I've talked to on implementations, including our own, we have a mapping layer. So you don't want to change it all the time. But because it's mapping from the model to a native representation anyway, it's not like you're as better to change it now for good than way down the road after people have written. Not only there's device implementations, but there's applications that people have written based on the model. Which is even worse, you know. So
the operator is much more the case to worry about than the vendor.
Exactly. Yeah.
Okay, now for the segment routing part. So just for the story, it was first included in the base model, then it was a dedicated model in the ISIS base draft, and now it's a dedicated draft. It's almost stable now. We have a small fix to add, which is this new pibet to add in the model, but apart of this, yes, it's almost stable and ready. So now, what do we do with this model? So for sure, I think we can update the base model with the routing policy call. And after, do we last call it or do we wait again?
Please finish.
And for the ISIS segment routing, so we need first to add this small fix. I think Yingsen, you will do it really soon. And after, maybe we should have a different last call strategy and maybe doing last call for the base segment routing model in Spring as well as the IGP draft at the same time. So in case there are some feedbacks, we can update all the models at the same time, just to avoid confusions and so on.
So can I ask a quick question? That the base model, is it last called, or are you suggesting they go together?
No, we can do it separately.
Yeah, I mean, but is your suggestion that the base and the IGP?
We can do the base, I think, now. And for the ISIS segment routing, do it with Spring.
I meant, yeah, I meant the base SR. So I agree. The base model goes without the segment routing. That doesn't block it. But we should also wait on the base segment routing.
Right. It's almost ready now. Also, I think we have some cross checks to do, but yeah, it's almost ready. Jeff?
Jeff is speaking as BFD chair. So to add a little bit of extra churn into things, your model does say, hey, we're using BFD. You've done the same thing that ISIS has, and sort of shut off most of what previously had been done, partially because of the BFD stuff was not advancing as fast as everybody was looking. BFD finally got cleared out. The network instancing stuff, stabilized. The schema mount has stabilized. My suggestion is it's time for perhaps you to take another look at what you would like to do with BFD in the model here. Schema mount is a possibility. I'm not suggesting any specific strategy at this point, but I've been asked to sort of speak to people to take a look at this problem.
Okay.
Do we think that can happen pretty quickly, like the turnaround on that, or is there sort of design left?
So at this point, the authors of the BFD stuff think that the module is largely stable. There's like one small hole in terms of BFD coverage for VCCV because they haven't gotten their act together. And there's a very good chance that we're just going to simply ship the model without that feature and revise the model at some later point.
But we don't have to block on your model, right? We just have to make sure we coexist in a good way.
Yeah, so unfortunately, depending on exactly what you'd like to do, the two strategies that were left there is what I believe is the model right now is basically yes, ISS or is using or is not using BFD. It's just a simple leaf node that's true or false. The problem is that
we have a container that you may be able to augment if necessary.
Exactly, and the question is really about what the augmentation is. BFD specifically set aside models to have common timers in there. That was the idea that for implementations that want to allow for the IGP to specifically suggest what timers to use, that they could. And very similarly, if you want to actually have a configuration state in there, the schema mount would allow you to do that. The problem with that is schema mount is newish in the grand scheme of things. You may know when to block. Doing it by augmentation may make sense. This is just mostly a matter about figuring out how you want to structure, this portion of, the leaves so that you could do the stuff in the future.
Okay, so could I ask you guys to maybe work together so we can try to get this wrapped up
Yeah, sure.
Cool.
Certainly. And again, I'm just sort of speaking, for the authors. Please talk to them.
Yep. AC Lindum thinks scheme them out is the wrong hammer.
Aliyah Atlas. So on the question about holding models back or what do we do for ensuring consistency, this is something that Benoit and I have been talking about for a few years in terms of how do we ensure consistency between the different models, and sort of getting a group of models that make sense to progress together is essentially a release. So what I think would be very helpful in that process is to take the models that the working group thinks are done in terms of accuracy and goodness, the working group last call them, and put them into waiting for implementation. Just say, we know this looks good, we're waiting to hear about the implementations and interaction. Not saying that they won't progress without implementation, that's not what I'm saying. I'm just saying put it in that state for now. It will be a great signal that that's what we're waiting for. And then I would also really welcome discussion on, say, routing Yang Horde about which models make sense to progress together, or what would that release chain look like if we think about Yang models as a software release instead of as documents that show up arbitrarily.
Any other comment?
Yingzhen, same as the OSPF, we need a young doctor to review this one. It's also a huge one.
Okay.
Thank you.
Don't remember who was up next. Oh, you remembered.
My name is Yao Hu. Let's talk about how to reduce ISIS flood in MSDC. ISIS is usually a routing protocol for MSDC network where clause is dominant topology. Within the topology, a given ISIS router will receive multiple copies of the same RSP from multiple neighbors. This unnecessary link state flooding will consume the valuable CPU resources on ISIS routers and make ISIS unscalable in such environment. The solution to address the bold issue is to mix the centralized link state information distribution and this distributed sorted path calculation. More specifically, all ISIS routers within the closed network are connected with the controller via management LAN. ISIS routers within the class just need to exchange hello packet. The link state information is only need to exchange between ISIS routers and the controllers. Here, the controller is elected as the DIS. To avoid the traffic from being flooded across the managed LAN, the cost interface to the management LAN should be set to the maximum value. When given ISIS lost its connection to the management LAN, it should actively establish adjacency with at least one of the peers within the class network. This is a rollback mechanism. To further reduce the flood of multicast ISIS packet over the management LAN, ISIS routers should send ISIS packets as unicast. For instance, ISIS routers should send unicast hello packet to the controller In other words, ISIS router should not send a hello packet until the DIS has been found for the management LAN. In addition, ISIS router should send other type of ISIS PDUs to the controller. Next step, since this 0.0 version, there are a lot of details need to be specified, and verification is being planned now, and I'm planning to gauge interest, especially from DC operators. Any comments?
I'm curious why you, what's the point of the unicasting on the LAN before disk selection?
Pardon?
You say unicast your hellos on LANs before disk select. What does that gain? I mean, that seems to make it longer, right?
Yes, but the point is to make LANs impact caused by multicast flooding over the net.
Is there a cost to multicast flooding over? Or it's not flooding, right? It's hellos.
Yeah, hello is multicast, right?
Yeah.
So when a router, OSPF router in cloud
ISIS.
and multicast.
ISIS router. ISIS router.
Yeah, ISIS. Hello. Yeah. All the OSPF routers.
ISIS router.
All ISIS routers will receive their multicast, right? So it's better to use unicast.
No, but the point is that when you multicast the hellos, everyone gets to see them, right? So it actually reduces the number of packets on the LAN.
Okay.
That might be an issue.
Okay.
Here comes OSPF.
This is actually a general comment. I think, and this is what we talked about this offline, that the big question in here is, I realize there are deployments where there is a management LAN connecting to every switch. I verified that with our product management Cisco. There are some, right?
Yeah.
Now, do we want to leverage that for this capability? And what about the reliability of that management LAN? I see you had something, if you lost the management LAN, you use a different,
rollback.
Yeah, rollback. You didn't have that in OSPF initially, draft. Maybe it's in, maybe I read it. It wasn't in the version I read. Maybe you updated it, Bill.
Okay, it had not been mentioned in that version. I will.
Okay, yeah. You didn't have you didn't have that capability. So those two things. Do you want to use the management LAN for this? And number two, for this to reduce flooding. And number two, what about the reliability of it when it fails?
Okay.
So Peter Lofberg, you know, I have a phone company background. You were describing SS7 and what they call continuity check is your hellos. But I would like you to see if you can elaborate on the backup model, right? Take your model and assume that control Ethernet is always broken. So take it out. Okay, it's always broken. And then you have this hand-waving backup modes. If you can figure out how the hand-waving backup mode works without the control Ethernet, you actually solve the problem.
Okay, thank you.
Yeah, I think, by the way, I don't know if Tony P's in the room. Tony Zagenda? No. Because yesterday he was saying that this horizontal link is almost never there. That was his opinion.
You mean
the management link?
Management link?
Yeah.
Management.
So anyway, maybe the point is maybe it's not that big of a deal. And just giving it a high cost and not using it, and not worrying about it. You don't think so? I mean, that is a horizontal link between the spines, right?
I believe that the discussion in RTGWG on this is Chris Bowers with Juniper about horizontal links had to do with the cloth fabric itself and horizontal links within a layer. Yeah, not the management LAN.
Okay, so okay.
Yeah.
So he was saying that the management land could be there.
Right, and
It's just not part of the forward.
And actually, Igor Gushinsky was saying, in fact, that they are there.
Yeah.
So that's still an open debate, but that was all about traffic carrying stuff in the cloths or modified cloths fabrics.
And so you were saying you wanted the cost very high in the management land so that it didn't do that, right?
In fact, the management land could be what you like as well. For instance, during the boat tramp period, there could be some protocol to calculate spanning tree and then create a dedicated land for management purpose.
Look at Peter. Look at Peter right now. Yeah. Okay. One more comment, I guess.
As Donald Eastlake from Huawei, just saying it would be interesting to have some figures on the amount of these precious resources which you say are being used by the current scheme. And I think you were talking about CPU resources. I'm not sure it takes very much to determine you already have a fragment and you can throw it away when you receive it. Redundant copy might be more link resources, but I'm not sure it's that much of that either.
All right, thanks. Oh, yes. Here we go. Let's see. Hopefully I get a new one. That's supposed to
Okay, I'm Les Ginsberg. This is the first presentation of this draft in ISIS. There is an equivalent draft in OSPF that's been around for almost 2 years and has been presented in OSPF multiple times. And for those of you who have attended OSPF, you know that we've had some pretty lively discussions. So we'll see what happens. What are we trying to do? Today, if you advertise link attributes, it's assumed that these are associated with RSVP-TE. We now have use cases for multiple applications that need to use link attribute advertisements, and we currently have no way to indicate what applications are making use of these advertisements for a given link, and we have no way to advertise application-specific values in cases where that may be necessary. This is the OSPF draft that inspired this work. So just some details, since this is the first time the ISIS draft has been presented, on how we go about doing that. There's a bit mask that specifies the applications, and this piece is used in a number of sub-TLVs and sub-TLVs. So what we have is, we have one bit that indicates that the applications that are identified by the subsequent bits will use the legacy advertisements that you're all familiar with for TLV22 and its companion TLVs. And then we have some bits defined for the 3 applications that we're aware of at the moment. There's a proposal for an IANA registry, so new applications can be defined, and the bit mask is variable length. So in theory, we could support as many applications as necessary. There will be one and only one new sub-TLV for TLV22 and its companions. It will start with the application bit mask that I showed on the previous slide, and then it will have link attribute sub-TLVs. These will have the same format as the existing sub-TLVs, and will use the same code points. Of course, these code points are sub-TLV code points, so there's no conflict here. We're also addressing the same issue for SRLG. So in this case, there will be a new top-level TLV for application-specific SRLG. It will identify the neighbor for which this particular TLV is associated. The same application bit mask that we used in the TLV22. You'll have a length of sub-TLVs, and then the link identifier sub-TLVs, which are shown below. These link local remote addresses, IPv4, IPv6. And then, of course, the SRLG values. These can be 0. And why could they be 0? Because we're using the legacy advertisement. So if in the application bitmask we've set the L bit, then we don't actually have to advertise the SRLG values in here. So here's a few basics on deployment cases and how this draft affects them. If you just simply have your existing RSVP-TE only deployments, there's no change. You use the legacy advertisements, not affected by this draft. If you have multiple applications, one of which is RSVP-TE and one of which is one of the newer applications, but the attributes are shared by RSVP-TE and the new applications, then we simply use legacy advertisements. We advertise the new sub-TLV, and in the application bitmask, we set the L bit, so we don't actually have to advertise link attribute values in there. This is backwards compatible. There's no duplication of the advertisement of the link attributes. We do have 3 extra bytes per link to indicate the set of applications that are the additional applications that are using the RSVP-TE, the traditional RSVP-TE advertisements. Here's a third deployment case where we have multiple applications, but not all the link attribute advertisements are shared. So we use the legacy advertisements for RSVP-TE. We use the new advertisements with the L bit clear. So you have the new sub-TLV that says, here's the set of applications. They're not using the legacy advertisements. And then, of course, you have the link attribute values themselves as sub-TLVs. This, again, is backwards compatible. You do have the potential for some duplication in cases where the new advertisements are sharing some of the attributes, but not all of the attributes. There's been some discussion about why do we need application-specific advertisements. So here's a few examples. Obviously, this is not exhaustive, and there may be many more that are defined in the future. You could use a TE metric, for example, to influence LFA selection, and the metric value that you want to use may be different than the metric value that you want to use for traditional traffic engineering. If for no other reason than you know you're using that link for traffic engineering and you'd like to have it less preferred for LFA. In the cases where you have SRTE and RSVP-TE, you may want to use different attributes so that you have different paths for those 2 applications. In the case of SRLGs, it's possible that you may have a different set of SRLGs to address what happens when there's some non-local catastrophic failure. For example, I don't want to send traffic towards a particular geographic area. There is, of course, alternative proposals, both in OSPF and ISIS. There was discussion in Seoul, in the OSPF working group, about both proposals, and the one thing that we did agree on is that, or the 2 things we agreed on, is that ISIS and OSPF should do equivalent extensions, and we should only do 1 extension. So this is a slide that summarizes the differences between the 2 proposals. The items that are particularly different here are whether per application attribute values are supported. In the case of this draft and the companion draft from Peter in OSPF, they are supported. The alternative drafts do not support it. The other significant difference is in backwards compatibility. Both the OSPF draft and the ISIS draft that I'm presenting now are completely backwards compatible. There's nothing you have to do to legacy routers when you deploy this. In the case of the alternative proposals, the only way to do partial deployment is to do some additional configuration on the legacy routers so they don't misinterpret the new advertisements as if they're for RCPTE. So obviously there's been significant discussion about this, both at multiple IETFs and on the list. And as always, the advocates of each position are pretty enthusiastic about their respective point of view. And I got to thinking about, how do we build some consensus here? And the things that make sense to me are backwards compatibility is clearly a desirable trait. So if you're simply looking at the two alternatives on the basis of backwards compatibility, it's better to have a solution that is backwards compatible than it is to have a solution that requires some manipulation of legacy routers in order to deal with partial deployment. I would hope that this is not a controversial statement. The second issue is in regards to the need for per application attribute values. Our proposal supports that, the alternative proposal does not. We have given some examples of use cases where that's needed. Even in the cases where if we never had today a use case for it, the perspective that I have is, well, we invented TE 15 years ago. Nobody ever anticipated that we were going to have a need for multiple applications, which is why we're sitting here today with two proposals to extend what we have. It's rather bold to say that we'll never have cases where we need to advertise different attributes for different applications on the same link. So if we're going to the trouble of extending the protocol, it seems very prudent to me to provide this additional capability. I think the other point I would like to make is that I do not see that the support of per link or per application attributes adds significant complexity to the implementation. I mean, speaking as a developer, if I'm going to support an additional application, such as the use of link attributes for LFA, where's my work? My work is in writing the code to take the link attribute values, use them in a new way, and have that affect whatever behavior I want to achieve. Whether I retrieve those values from a legacy advertisement or a new advertisement plays a very small role in the work that I have to do. So obviously we want to move forward with working group adoption, but the first thing that the working group has to decide is which of the alternative proposals the working group wants to go forward with.
So I have this is Chris Bowers with Juniper. I have a clarification question. So moving forward, if we define new values that would go into TLV 22, like assume that we just sort of move forward with business as usual, a new link attribute, if we were to adopt your proposal, where would these go? Would they go in both 22 and the sub TLV? Would they be, so we're going to define a new sub TLV of 22, which is 77, right? Does this now also do we define it there and also define it in the sub TLV of TLV, sub TLV 15 that you've proposed?
So I think the expected answer is probably yes. We would probably set up the IANA. We have a new IANA registry that would have to be defined by that. And I think when you added a new sub TLV to TLV 22, It could be evaluated if it's applicable to this new sub-TLV as a sub-TLV code point, then we would add it there as well.
Okay.
Because it's obviously less confusing to have the same code points.
Right. So would you ever see a scenario where you would, and I'm against this, but I would want to explicitly say, do not define stuff only for the sub-TLV of sub-TLV 15 of TLV 22. I think that would be something to explicitly point out.
There, no problem.
Okay. Other, so I had another, the conversation yesterday was actually kind of productive in terms of thinking. There may be some room for a common ground on advertising multiple values of the same attribute. But I think that to really future-proof this, it shouldn't be per application, but instead, we shouldn't hardwire the applications into what ISIS is advertising, but instead have something like an attribute group ID. So functionally, it looks a lot similar to this, but this would just be an arbitrary identifier so that just as you've done in here where the application, the value of 0, and using the analogy of multi-topology IDs, the attribute group ID of 0 would never be advertised in the sub-TLVs or in the sub-TLV 15. And the values at the top level of TLV 22 would implicitly be 0. So that we get a framework that honors the existing role of the TLV 22 attributes and the fact that they're running networks today and should not be disturbed, but allows us to advertise multiple values of the same attribute without linking them to a specific protocol. Because SR isn't really an application, it is a protocol. And one can easily imagine a scenario where you want to have two applications that want to take advantage of two SR-based applications that would need two sets of attribute groups.
So the term application is a pretty broad term. And if there are two flavors of users that are associated with segment routing, we can allocate 2 bits. I don't see a problem here.
I think that it would make more sense to begin with to not try to hardwire the applications in here and simply have an attribute group ID so that we're truly future-proofing this against applications that we do not foresee.
So I'm not sure, I see Stefan is already up, and he mentioned something to this effect in OSPF yesterday. So if what you're suggesting is similar to what he's suggesting, I think this is certainly a topic for discussion. This is about, get the document as a working group document, and you can now say, gee, I don't like to use these hardwired bits. I would like to do it another way. This is a point we can certainly discuss. But this does not change the general approach. The sticking point at the moment.
I think that it would behoove us to resolve these issues before it becomes a working group document, because as it is, until we resolve these issues, these discussions, enthusiastic discussions, will continue.
How do you correlate? The difference that we're trying to resolve is, do we need application-specific advertisements or not? Okay, the debate is not about how do I identify the application.
So this has been contentious enough that we should solidify it in the text before we adopt the text. So I can either propose text to modify this to do it. I can modify my draft to do that. We can go a number of ways.
I
I'm
suggest
open.
that if you're willing to incorporate his idea and it moves us forward, that's great.
So-
That's the closest I've seen you two on this. So
I'm neither agreeing nor disagreeing with you. I'm saying this is work. This is like any other draft that comes into the working group. It comes in as V0, and it eventually goes out as VNN, and in between there are changes. But this is not what the debate is about. Okay? The reason that we're debating whether we should go with, this proposal or that proposal, I don't think hinges on the revisions that you're talking about.
So should I modify my draft instead? Because I sense that that's saying, what do you want me to modify the text of this draft?
I'm not proposing that either draft get modified because I don't think that's the call that the working group needs to make.
So I could potentially support adoption of a draft that incorporates these changes I'm discussing.
that sounds great. Why don't you guys work together, please, and just like get one version? It's so much easier to adopt the document as a working group document if we don't have anybody disagreeing.
Okay, Robert, I think Chris just agreed that per application makes sense. So it's all golden, right? And my comment is about not hardwiring really as well. And on the list, OSPF list, I sent an idea to actually have a local significant bit, right? So you can actually configure what bit corresponds to which application. If it's SR instance 1, SR instance 2 on a given router, it's a little bit more overhead, but it gives you the abstraction without going too far into some new values.
And again, my response is the same to you as I've done both publicly now and privately.
Yeah, and it's working group
which is
thing.
I'm very open to discussing that. Let's just work on the draft.
Yeah, Stéphane Kossi for Orange. Yeah, having something generic is really important, and more. In addition, it will solve the conflict part that you are currently defining as undefined behavior. Because it's not really good to have an undefined behavior. Undefined may be router crash.
Hi, this is Uma Chanduri. So I like the backward compatibility option here. It's good. And also I'm very happy to see that, per application values for different attributes, you both are agreeing, which is good. So now I like the idea, it's better to don't put applications here, it's group it, whatever Chris said, I like that. So probably it's kind of match because it's mostly 90% of things are agreed upon. So how to do this?
Oh yeah, Atlas. So if you can go back, in your comparison, you're talking about backwards compatibility. And I'd like to ask a clarifying question. Why do you believe that there are no backwards compatibility problems with that? Because my understanding is that until the SR work came along, when, for instance, we were looking at LFA, there was we can just reuse SRLGs for LFA and similar types of things. Sorry? Yes, TE SRLGs. It never entered the realm of conversation, and that we would want to flood them multiple times depending on what was using. So I'm not making a comment on this particular proposal, but I do agree that the backwards compatibility question is one of the pain points. What I have not heard, or my impression is, both of the proposals have backwards compatibility issues depending on particular implementations. I'm happy to be educated offline, but I am saddened to believe that you have not heard this information, given how long the discussion has been going on and how vehemently it is being discussed.
So if you, try to keep this brief, but if you go back, Peter's draft was submitted, I believe, in July of 2015 when it first became a working group item. And it's been that long. Okay, I checked it this morning.
Believe you.
Yes. And initially, and quite frankly, I was even among them. I was not convinced this was a problem that needed to be solved. And all credit to Peter, he persisted in the face of people saying, we don't need this, we don't need this. And my reading of this, both because of what I became convinced of in this draft and the way Peter's draft has evolved, and also the way Chris and Schrader's draft has come to be, is that we have a common belief that we do have to deal with this problem. We have had some differences of opinion about how to go about doing it, but we've recognized that overloading the existing advertisements means that we have no way to say this is for RSVPTE and this is for SRTE, and no way for legacy routers to say I shouldn't use this information because the only thing I support is RSVPTE. So I think that's how this came about.
Oh, I'm not questioning the need to resolve the problem. I'm questioning the claim that the backwards compatibility impact is only in one direction. And that's...
So backwards compatibility to me means I can roll out routers which support the, these new extensions, and I'll have no impact on the operation of legacy routers that don't understand that.
I think there's one thing.
AC Linda, I think there's one thing that the ISIS draft has that the OSPF draft doesn't have yet. That's an option that says use the TE values for this.
Okay, I have it.
Oh yeah, right. So that would if we had that, then we'd have that too.
Yeah, so this is Chris Bowers with Juniper again. Just like I really would like an explicit statement about new sub-TLVs of sub-TLV 15 of TLV 22 being only defined if they're defined in TLV 22. I would have a similar request or requirement to support the OSPF draft that anything defined would also be available in that the existing TE LSA.
Yeah, I mean, I think that's something that, I'm speaking a little bit out of turn here, but I think that's something from the OSPF perspective that could be discussed. I think in OSPF there's been some resistance because there are two different containers for this information, so it's a little more awkward to merge them together, but I think it's something that we can certainly discuss.
So just to finish up, in OSPF, as of course you know, but for the working group, what I said is let's work on having a virtual interim soon between OSPF and ISIS, focusing on this issue and these documents to try and nail this down. I don't want to have this discussion happening again next IETF.
Okay, so to that, I think I heard things today that might even avoid the need for a virtual interim. If Chris and Les can get together, it sounds like Chris is closer to going along with your proposal as long as you make some changes that he wanted that don't seem against what you're trying to get done.
Please contact me.
It would be wonderful for them to work together. If we have a virtual interim and we all say, hi, it's great chatting with you, and there's no controversy and we close it in 15 minutes, that's wonderful, but it's still a useful checkpoint.
Okay.
I think with OSPF, I don't own the implementations at Cisco, but I think as long as you could get your network to a point where you didn't need the backward compatibility, adding the backward compatibility would be a good idea. And then you'd support, then you could support partial deployment. You could do SRLGs using either set, right?
Yeah, I mean,
I think we should discuss that for OSPF too, and then and because since you have it in ISIS, we discussed that, but we'll
sure.
Yeah.
Okay.
My main concern is having the cleanest, the smallest LSDB possible.
So we are the last session, so I guess we can run a little bit late. Anyway, no, yeah, some people just don't want to be here.
You folks have no place to go, right? This is
We still have 30 minutes left, but
Okay.
maybe you could go faster on this one.
Okay, this is the ISIS extensions for SRV6, another new draft. A slight bonus here, I'm going to give you an update on the existing ISIS segment routing extensions draft, which has always been only about the MPLS data plane. There was, in the early days, there was some thought, well, maybe when we start dealing with SRV6, we'll add SRV6 in there. But that never came to be, and it makes a whole lot more sense to us to close the SR-MPLS work and move on with the new draft for SRV6. So we've done some minor updates. We moved a couple of things that referenced IPv6 that were relative to SRV6 that were never implemented, and we've made some explicit statements that this draft is SR-MPLS only, and we are now ready for last call. So, request to the chair.
Yeah, what does the feeling in the room? How many people have read this draft?
The existing draft, not the new one.
How many people would be in favor of adopting or last calling this? I'm sorry. Okay, it looks pretty supported. We'll ask on the mailing list.
I think we've all been looking forward to this day.
Okay.
Okay. A couple of other related documents. There's a bunch of SRV6 documents that have come out at this IETF. Please read them. I don't have time to go into a lot of the basics here that are defined in these drafts. So there are some questions if you ask, I'm going to say, go read the draft. I don't mean to be rude, but we just don't have enough time. What do we want to do? We want to define some protocol extensions in support of SRV6. I should point out that you can deploy SRV6 without these extensions. These extensions are needed only if you want to do things in addition to the basics, some things related to fast convergence or traffic engineering, for example. So what have we proposed? We have a new sub-TLV in the router capabilities TLV. We have a new top-level TLV to advertise SRV6 SIDs. We have two sub-TLVs for neighbor reachability, and we have one function descriptor. So in the SRV6 capabilities sub-TLV, we have a, I'm sorry, in the router capabilities TLV, we have a new sub-TLV to advertise our ability to support SRV6. Note that the existing sub-TLV in the ISIS SR-MPLS draft now only indicates support for SR-MPLS. So there's no overlap between the two. There is one flag defined in the flags field at the moment, which is that the function tncap is supported. I'm not going to talk about the functions. Go read the functions draft in the Spring Working Group. For the rest of the fields, this defines the maximum SID length that you can support in a segment routing header, the maximum that you can pop when you're applying either penultimate or ultimate popping behavior, insertion, encapsulation, the maximum number of SIDs. Again, all of these functions are defined in the SRV6 functions draft in the Spring Working Group. Please take a read on it. We have a new top-level TLV to actually advertise IPv6 SIDs. We had some debate about whether this should be, so SIDs in IPv6 are a form of an IPv6 address. So it's conceivable that we could have put this under the existing prefix reachability, but we concluded that was not a very good fit because SRV6 themselves, when you advertise a SID, this does not mean that you want to put reachability into your ribbon FID for that destination. So if we had put it under the existing prefix reachability TLVs, that means we'd now be advertising a bunch of stuff and potentially triggering SPFs when there's no reason to trigger SPFs. So it's much cleaner to have a top-level TLV. It does share the same sub-TLV space with the prefix reachability TLVs, 135, and more relevantly, 236 and 237. So there are some sub-TLVs that we can borrow from there, and then there are some new sub-TLVs that we define. The SID itself does not necessarily need to be covered by prefix reachability advertised by ISIS. You could have a static route, for example, that covers that particular SID. The TLV itself has some flags. It has the size. This is very comparable to how we advertise prefixes, where you indicate the prefix length and then the actual prefix itself. So we followed that exact model. And then you have sub-TLVs. There is one flag defined at the moment, which is the down flag. Again, very comparable to what we do for prefix reachability. It gets set if you were to leak this information down from level 2 to level 1. So this prevents you from leaking it back up. And again, following the prefix reachability model, you can encode multiple SIDs in a single TLV. There are a couple of sub-TLVs for this new TLV that we've defined. One of them is for point-to-point, and this is used to advertise the SIDs associated with EndNode behaviors. Again, not going into detail on the behaviors. Please read the functions draft in the spring working group. We can also put sub-TLVs. I'll talk about the sub-TLVs that we've defined for this in a minute. We have a comparable sub-TLV for the LAN case. And obviously in this case, we have to insert the system ID of the particular neighbor on the LAN. And this is the function descriptor. This gets encoded as a sub-TLV if it's in the SRv6 top-level TLV, but it gets encoded as a sub-TLV if you use it in the point-to-point or LAN sub-TLVs. So it's a container for advertising an SRv6 function associated with a particular SID that you're advertising. And it describes a particular behavior with some optional, the term we're using here is flavors. And you can encode multiple of these for a given SID. So what does the behavior look like? It has a particular function. It has flags. Right now there are 2 flags defined, one for penultimate behavior, one for ultimate, or flavor, I should say. And the function actually encodes the function code point, which I guess I didn't put in there, but there's a set of, I believe, 4 or 5 functions that we've defined. Will be in the draft. So next step, obviously we'd like to move this along to working group adoption after people have had a time to digest it.
Okay, so well, you sort of qualified that with after people have had time to digest it. So should we just do this call on the list, or do you think?
I'm happy to do the call as soon as you feel comfortable.
Yeah, well, I mean, how new is it?
So this was published 2 weeks ago, 3 weeks ago, something like that. Pretty new.
Yeah. Well, let's. How many people has anybody had a chance to read it yet? 1, 2. Okay. Those 2 people might or might not support you. I don't think it really matters.
I'll talk to them privately.
Oh, AC, I know you'll support it.
I'll support it. I have to admit that I didn't dare read it because I hadn't finished reading the network programming draft yet.
Yeah, that's definitely a prerequisite.
Okay. let's get on. Thanks, Les. Naming. Come talk to us about data center topologies from 50 years ago. Where is it? Oh, there.
I'm Naming Shen, and this is the draft. The similar draft I presented yesterday in the routing area working group. And here's the agenda summary, basic, TLV formats, and the special case for the Pew class and the discussion section. So this draft, the first published in November 15, and the most recent version was presented in RTGWG interim meeting for data center in January. And the new version is based on top of the basic spine lever extension, and we added the negative routing or conversational learning portion to support the pure class topology. And this draft is zero flooding and zero topology for TOS switches, and enables ISIS routing fitting better in DC and enterprise networks. So I have two slides of the examples. This is to cover the basics. And we have two layers. The top layer, we run the normal ISIS. And for this one, between the levels, and this is how this extension works. The leaf will know it's a leaf and send a TLV with a special flag indicating it's a leaf node. And the spine which supports this will set the S bits to say, yes, I support this. You can use me as the default next hop. And for the leaf receives from all the spines, and it just set default to all the default next hops. And let's say we have another layer on top or multiple layers on top of the aggregation layer. And when there is a link down between the spine and the leaf, you could have reroutes the traffic through alternative paths to reach the destination. So again, this is a zero flooding and zero topology. There is no topology information on the leaves. There's no OSPF calculation over there. So this is the TLV, and the mandatory portion is 4 bytes, and there's 2 bytes flag, and currently we have 3 bits defined. So for this new version, yeah, hi.
So, Julius Krobachek, sorry if I say something stupid. I've just only heard about that for the first time in my life, so I'm probably going to say something stupid. But is that not equivalent to putting each leaf in its own area?
Putting
which would
each
require no
leaf
extensions.
in its own area. Yeah, go ahead.
So I think the answer is no. What we're trying to do here is minimize the flooding. So the information that is originated from the leaf goes in, gets sent up to the spine nodes and becomes part of area X that the spine nodes are participating in. It's just that the leaf node in most cases, only needs default routes in order to forward things that are not directly connected to him. So we're not separating, we're not building more areas. We're just reducing the amount of information that has to be stored on the leaf nodes.
No, the problem you're going to run into there is the difference between OSPF and ISIS with areas. It doesn't look like that in ISIS, right? So you'd have the router above would have to be in multiple areas for that to work, and that's not how it works.
Yeah, I also think it would be.
It's much closer to being stub router, like a not a stub, overloaded. You can think of the leaves as overloaded, I think, in this case.
Yeah. It would also be problematic, I think, for provisioning, trying to auto provision individual areas on all the leaf nodes.
And you also need to leak all the other levels routes into your level or into your area in order to have reachability anyway. So in this, I was trying to mention the last bullet, which is the new draft, which has the sub-TLV running in the constraints circuit scoped LSP. And we have two sub-TLVs. One is leaf set, the other is information request. So in the pure class, this kind of a topology, let's say there is no horizontal links, and which is true for a lot of data centers. And even you have the upper tiers connection, and the people may not want to reroute through those upper connections, which will be non-optimal paths. So you need to give some information because we lost the topology, that information. So we are doing conversational learning. When there's a bad things happen, we inject more specific information into this. So let's see the upper two layers is running a normal ISIS, or you run multiple levels of ISIS. And the bottom two layers is running this extension. This on the right side, let's look at the link down event. And what this is the new sub-TLV we introduced is the spine nodes will advertise how many leaf nodes I'm connected to. So this is the leaf sets. So in this particular case, the S3 and the S4 both will say, I'm connected to 4, 5, and 6 of the leaves. Now, the L4 will say, okay, because all the spines advertise the same leaf sets, so I can just do a default route to both S3 and S4. In this particular case, let's say it wants to reach one of the prefix on the L6, and it happened to choose this S3 as the default gateway. And now, if the S3 to L6, the link is down, what happens is this leaf set advertised by the S3 will miss this L6 in its set. But the S4 still have this, right? L6. So L4 looked at this S3 and S4, realized S4 advertised something the other guy does not have. So it can use this sub-TLV to do a request saying, hey, I know you say you got the L6. Okay, give me the information behind the L6. So we advertise, let's say V6 or V4 or SID information, inject them into reply to the request by the L4. And the L4 got this specific prefix information for this example, P1 and P3. It will install those two routes into the routing table, points the default route to the S4 only. Yeah, go ahead.
Nico Stradafili's question. Bear with me, because I'm not an expert in ISIS. So effectively, you're saying that the leaf nodes, every time they see a difference, they have to go and compare across all the information that they got from the spine and figure out what am I missing.
Yeah.
So
let's say you got 10 spines, right? You got 10 spines. You can randomly choose one. Let's say
I have 32 spines.
Let's say you have 32 spines.
How's that?
One spine says I'm missing L6, right? No. You can ask one of the 31 spines which all advertised L6, right? And you can randomly ask any one of them saying, give me some information because, so any leaf can randomly ask.
Right.
I hate to do this, but we only have 5 minutes left and there's 2 more presentations.
Okay.
Can we come back to it afterward?
Yeah, my concern is how computationally expensive this is if you have many and you have many prefixes flopping and linked.
Thanks. Right. And could you wrap this up?
Yeah, sure. And this is the reroute, right? So in the node down case, there's nothing much you can do because the spine will withdraw, both of them will withdraw this advertisement. So there's nothing changes. So it's still default route to both of them. And if the spine node itself down, you lose the connection. So you get one less default next hop anyway. So there's nothing you need to do. Now, the discussion is
wrap up means like you have no time left.
So so what I'm trying to say is we are talking about the DC and there's so many features have been developed on both BGP and ISIS, all of things. We can reuse that capability. And we can also do TE. And the discussion is ongoing with the Open Fabric co-authors to see how can we combine some of the signaling together into one draft. So we welcome for the comments and the reviews.
Thanks, Naming. Sorry to rush you. Which one do you want first?
The first one.
Black hole? Which? Black hole avoidance or overhead reduction? Okay.
Hi everyone, I'm Zhe Chen from Huawei, and I think this draft will answer the question this gentleman just asked. So let's see the motivations of this draft. When we use ISIS in highly symmetric topologies such as countries or span leaves, the leaf node benefits little from learning the whole topology. So, but the original ISIS functions such as in area partition or the multi-level functions cannot solve this problem. So in this document, we propose that the ISIS router should check the area identifier before advertising RSP. So the operators in this way can use the original ISIS functions to prevent leaf nodes from learning the whole topology. So this is a very simple example of this solution. Here we can assign error 1 to the span node and leaf 1, and assign error 2 to the span node and leaf 2. And the span node should be configured as level 1 and level 2 routers, and the leaf node should be configured as level 1 routers. So according to the current ISIS router, the leaf nodes will still receive the explicit route from the network, because in this example, Leaf 2 will advertise prefix A and B to span 1. And span 1, since it is in the same area with leaf 1, it will still advertise the prefix to leaf 1. So this is what we do not want to see, right? So in this structure, we propose that ISS router should first check the error identifier before advertising an LSP. So in this example, since the span 1 can notice that the prefix A and the prefix B is associated with error 2, but if 1 is associated with error 1, so it will not advertise the prefix to leaf 1.
So can I ask a clarifying question here? Are you just saying follow the standard? Are you just saying follow the standard?
Yeah.
Okay.
Sure. So here is the...
Sorry, just I'll make this quick. This is not following the standard.
To not advertise LSPs from one area
in
to another?
ISIS area addresses, if you have multiple area addresses on a node, they are synonymous.
Yeah.
I'm not saying you couldn't possibly invent a different algorithm, but this is not standard ISIS.
Right. So when I saw area 1 and area 2, I actually imagined how you would really implement that, which is 2 instances of ISIS. I mean, that's the only way, because of what you just said, right? Because it's not area 1 and area 2.
Okay, so here is the details of this approach. Before an router advertise an LSP to a neighbor, it should compare the AIDs associated with the LSP and the AIDs associated with the neighbor. If they have at least one AID in common, the router should advertise the LSP to the neighbor. Otherwise, the router must not advertise the LSP.
Okay, so no, I didn't mean to confuse things. You're saying that that top router up high is one instance. It has 2 areas configured, and the routers below only have one of the 2.
Yeah, that's
okay.
That,
so that does not follow the standard. That's in violation of the standard.
Okay, so since we changed the processing procedures of an ISS router, we have discussed about whether this modification will affect the current ISS usage. But the answer seems to be no, because in your cases, an ISS router is assigned no more than one error ID, except for the scenarios that the operators want to do error modification, merging, or partition.
So I have a question. So your example only showed 2 routers in the leaf areas. What if there's 32? Are you going to do 32 areas? Because it's not going to work for you.
Yeah, that's
okay.
what we are going to figure out. So the next steps, we need more reviews and comments on this draft.
Okay. Yeah, so Les is like half out of his chair, but okay, so we'll make comments on the list. We have one more presentation for you. By you. If I can find it. What was it? Yeah. Oh, there it is. Hang on. Windows. Oh my God, I found it. I'm new to Windows.
Okay, here is another 00 draft named Avoiding Traffic Black Holes for route aggregation in ISS. So here is the problems. When we use ISS in symmetric networks, as discussed above, we also want the leaf node only maintain a default route, and the next hop is all the span, right? So if link failure happens in the network, for example, if the link between span 3 and the leaf 4 is broken, leaf 1 will not know this event because it receives no link state. So it will still send traffic to span 3, thus causing black holes. So in this draft, we are going to extend ISIS to advertise unreachable prefix. So in this example, span 3, after the link failure, will advertise prefix A and prefix B to leaf 1, 2, and 3. So on receiving the unreachable prefix, the leaf node can install prefix A and the prefix B into their adopting tables, and the next hop should be span 1 and span 2. So here is the TLV encoding. We introduce a new ISIS TLV named IP and unreachability TLV, and here is the TLV format.
Yeah, something's really messed up on my side too. I'm sorry. So it's your slide is next steps, right?
Okay.
I'm really sorry about this, but it's like my computer's freaking out. Now it crashed. Okay. Okay, sorry. So the best thing to do is reload it. Yeah, flooding black hole. And then, oh, you got your slide, right? Is it working? Okay, sorry.
So here is the details of this approach. When link failure happens between a span node and a leaf node, the span node should encode all prefix attached to the leaf node into the IP unreachability TLV and append the TLV to the LSP and send the LSP to every other leaf node it connects to. And on receiving the LSP, the leaf node should install each of the unreachable prefix into its routing table and set the next hop to be an ECMP group, including all span nodes except the one who advertises the unreachable prefix. So we also discussed an alternative solution about this. So we are going to introduce a new sub-TLV of the extended IP reachability TLV defined in 5305. And here is the format of the sub-TLV. And when a link failure happens, the span node should advertise an LSP to the leaf node, which contains the extended IP reachability TLV carrying the default route, with the new sub-TLV carrying the unreachability prefix. Okay, the next step, we are going to add IPv6 support in this document, and we also need more reviews and comments. Thank you.
Okay, Ms. Ginsberg, can you just go back to the unreachability TLV? Yeah. Okay. So this is being advertised in the LSPs generated by the spine, correct?
Yeah.
And does he flood this information to other spine nodes?
No. No, just the leaf node.
So he has to segregate this information into an LSP that only gets flooded to the leaf nodes?
Yeah. But how it identifies the leaf nodes is on top.
Okay, but you've now divided the LSP set that's generated by the spine node into two pieces. Sort of the general set with all the information he normally generates, and he sends that to everybody.
Yeah.
And another set of LSPs.
Yeah. Just for this specific case.
Okay, this kind of complicates life.
Yeah, that's funny. It says the person with the flooding scopes. but no, the point is it's sort of inelegant that you have these doppelganger LSPs hanging out in your database.
Well, this probably goes beyond what we should be talking about here. But what occurs to me when I see that is you've done, in a sense, exactly the opposite of what Naming and I proposed in our draft. Okay, but the information, because we just send reachability, as requested from one of the nodes that's still connected. But we're doing that with a circuit scoped LSP. So it's not part of the set that the spine sends to other spine nodes.
Yeah, I was going to ask that question. I thought that the same thing is you're working on his work? I mean, are you taking the naming's work, naming less whoever, or is this totally outside of that?
Actually, this work is inspired by naming's work.
Yeah, so so this sort of strikes me as sort of copying their solution in a different way, right? I know you don't do that. I don't want you to say yes to that, but it's sort of the same solution, but
it's a different way, I think.
Okay.
Well, I have a comment on the negative advertisement. When a spine lost a leaf, right?
Yeah.
When you advertise that prefix, which means you have to remember what that leaf used to advertise to you, right? So you cache the stale information. The leaf can change in whatever way it wants, right? But you also only have the previous incarnation of the route's information advertised to you, right? This is one problem. The second problem is, let's say that particular leaf never joined that spine. So it's still missing. You never know that leaf existed before, right? How do you even advertise that negative route information, right? Yeah. So we thought about that when we came out with our solution is we got to advertise a leaf set to let the leaf to pick what information it needs to get, right? So that is the difference from our two solutions, right?
Yeah, but a solution to this problem, I think maybe we can install some static configurations on the both track of the network. So the spine nodes will have an overall view of the network, so it can know which leaf is broken down and which.
No.
Okay. Okay. Maybe we will figure it out next version of this stuff. Thank you.
All right, so Alia reminded me there's one more really exciting thing going on. I'm not actually sure I know. Tell me if I do it wrong. So we have a liaison from the IEEE. They've allocated a new ether type for jumbo LLC frames. Is that correct? LLC. We're talking about LLCs, right?
Yes. So, Aaliyah, Atlas. So, as I understand it, we had a draft which expired a long time ago for jumbo LLCs, and there was an ether type that was allocated for it. Unfortunately, the ether type wasn't allocated by, say, the IETF, which would have been useful, and the draft expired. And now the IEEE can't actually find the law firm that appears to own that ether type at this point in time. And therefore, what they have done is gone forward and made a standard and allocated a new ether type for the functionality, but it's exactly the same functionality. So I wanted to call people's awareness to this in case they had implementations of that expired draft using the old ether type, and also in case they were interested in saying, oh, this is lovely for ISIS and there's something that needs to be done here.
So
that's all.
So we do use jumbo frames in the internet and ISIS.
Yeah, this is
so sort of the person who owns it is the internet.
This is huge.
Yeah,
I mean,
they can't.
The draft never proceeded, is my recollection at the time, because the IEEE didn't believe jumbo frames should be used. But everybody implemented it anyways. So I can't imagine how many implementations are impacted by this. They just busted a whole bunch of stuff.
So Les, thank you for the perspective, because I was not paying attention to this aspect of ISI. I don't remember paying attention to this aspect of it then. That's what, okay. So, all right, so this is going to be fun. I'm glad that I brought it up. We will send the liaison here. The good news is what I have heard is what they standardized is exactly what was in the draft, and therefore what's in every router. The bad news is they're using a different ether type.
Yeah, that, so, yeah, so.
So it doesn't, no, so if it's a so yes, I know. Right, so if anyone's better at figuring out who owns the bloody ether type that everyone's using.
We do, right? By fiat. We deployed it everywhere in the world.
Okay, so.
Yeah, I don't know, I don't think anybody knows. Yeah.
So they did try and track it down. It was registered 20-some years ago to some company, and even the person who was there doesn't know where the IPR is, right? They don't know who owns the ether type, and they can't deallocate it because that's against their charter. So what I think we should do, since it is clear that there is excited energy about this. Yeah. Oh, sorry. Yeah, go for it.
So as long as that ether type is only used with multicast addresses we own, for example, then it doesn't really matter because there wouldn't be any conflict.
No, we use it for unicast too, right?
I guess. And so the right thing to do is
PSMPs are unicast.
the right thing to do, obviously, is to approve what's there. But if we're more going to change the ether type, you could actually save a few more bytes by using this convenient ether type that Trill uses to mean it's just plain an ether type labeled ISIS frame, and there's none of the LLC gap probably in there.
Okay. So I hear you, but it sounds to me like I would like to lean on some folks who are willing to volunteer to reply back with a liaison. And for those of you who have suggestions or appropriate connections to try and hunt down what's going on with the ether type. I mean, the IEEE did try to hunt down the ownership. So I don't think that we can send back a liaison to the IEEE saying, we hear you and that's lovely, but darn it, we want to use the same ether type because that's deployed everywhere on the bloody internet. So.
Yeah, you can. Yeah.
Let's have some discussion.
Okay, my note taker is leaving. So this is all off the
No, I have to get to a meeting too. Let's get together. I wanted to raise it because I thought it was going to cause some reaction. And let's talk offline. No one's making it.
This was not just allocated for ISIS. It was a generic solution for 802.3.
Yeah, I know.
So,
yeah. Thanks, everybody. Next time, maybe I'll get 2 hours.